Now, the next topic under systems of linear equation in two variables is solving its solution. So we have three methods on how we could solve for its solution. We have graphically, by substitution, or by elimination. Now, the first method says here graphically. So when we graph a solution or the linear function, we're gonna have here two lines which either coincides or intersects. Now, where the coincides or intersect, that would be the solution of the system. And we have here the three kinds also of system of linear equation in two variables. The first one is we have consistent independent, which has only one solution, since the graph would look like this. As you can see, it will only intersect in one point. So the solution is this one. The second one, we have the inconsistent. So when we say inconsistent, it has no solution, since the graph would look like this. So as you can see, it's a parallel line. They will never meet in the graph. The third kind or type is the consistent dependent. It has many solutions, since when we graph the linear function, there will only be one graph. So they meet in every point of the line. So the solution is infinitely. Solving systems of linear equation in two variables. So in the last video, we've had the first method, which is graphically. Let's now proceed with the second one, which is by substitution. So I have here the 4 steps on how we're going to solve later on. So I want you to read it first. Since it's called substitution, we have here the step substitute already. So it's one of the primary steps for us to solve for the values of your x and y. Okay, let's have an example of solving systems of linear equation in two variables. Graphically, that would be the first method, but for now, let's use substitution. So I have here an example, and I already labeled the first equation as equation 1 and the second equation as the equation 2. So for us to solve or to do the step 1, which is we solve for one of the equations, for one of the variable, we find a term which has a constant of 1. So in the first equation, we don't have any constant, which is 1. For the second equation, we have here y. So it has a constant of 1. So let's use this. So what we're going to do is we transpose your 4x to the right side of the equal sign to isolate y on the left side. So this would become y is equal to negative 4x plus 24. There. So that's our first step. Now our second step says that we now use this expression to solve for the first variable, which is your x. So we're going to substitute this one using, of course, the other equation. So we use equation 1, which is 2x minus 3y is equals to negative 2. So substituting negative 4x plus 24 to y, we have 2x minus 3 times negative 4x plus 24 equals negative 2. So using your distributive property, here we multiply your negative 3 to negative 4x. So we have 2x plus we have 12x, and negative 3 times positive 24 is negative 72 is equal to negative 2. Now, let's simplify by adding similar terms, which is 2x and then 12x. So that would be 14x minus 72 is equals to negative 2. Now after that, we now transpose your negative 72 to the right side of the equal sign to find or to isolate the x variable. So we have 14x is equal to 72 minus 2. So that would become 14x is equal to 70. Divide both sides by 14. 14 is the constant of our x. So we now have your x, which is equal to 5. So this is the value of my x already. Now the third step says that we solve for the variable, and that's what we did using the steps here, distributive property. Here we use simplifying by adding similar terms. Here we transpose negative 72, so it became 14x is equals to 72. And we divide both sides by 14, which is the number before your x or the constant of x, to find our answer, which is x is equals to 5. Now we still have the last step, which substitute the value of the variable to any of the equation to solve for the other variable. Since we solve for the x variable, we now solve for the y variable. So let's try to see. I will use equation 2 to solve for the y variable. So we have 4x plus y is equals to 24. We substitute the value of your x, which we solved earlier. That is 4 times 5 plus y is equals to 24. So 4 times 5, that is 20, plus y is equal to 24. After that, we transpose your 20 so that we could find the value of your y. So that is 24 minus 20, which give us the value of your y, which is 4. So there we have the value of your x and the value of your y. So your x is 5 and your y is 4. Second example. Let's have the second example. So in here we have the equation 1 and equation 2. Now in equation 1, we don't have a variable which is equal to 1. I mean constant. So in equation 2, we have here your y, which has a constant of 1. So let's use this. We simply transpose your negative 3x to the right side of the equal sign. So that would be y is equal to 3x plus 2. There. So after that, we use your equation 1. 5y is equal to negative 15x plus 10. So we substitute 3x plus 2. That would be 5. 3x plus 2 is equals to 15x plus 10. After that, we use distributive property to simplify the right side of the equal sign. So that's 15x plus 10 equal to negative 15x plus 10. Now for us to simplify, we transpose negative 15x to the right side. 15x plus 15x plus 10 is equals to 10. After that, we simplify. 15x plus 15x is 30x plus 10 is equal to 10. And after that, we again transpose 10 to the right side of the equal sign. So that's 30x is equal to 10 minus 10. That will give us 30x is equal to 0. After that, we divide both sides by 30, which give us the value of x, which is 0. Now, using the value of your x, we use equation 2. Y is equals to, y minus 3x is equals to 2. So substituting value of your x, which is 0, y minus 3 times 0 is equals to 2. That would be y minus 0 is equal to 2, which give us the value of your y, which is 2. So we now have the value of your x and the value of your y. Now in your seat work, this is how I'm going to give points to your solution. So this one would be 1 point. The substitution part would be 1 point. The solution, all of this would be 2 points. The value of your x is 1 point, and the solution here is 1 point. Of course, the value of your y would be 1 point, which would be equal to 7 points per number. Okay,